Problem 4-26 says consider the arithmetic sequence 2, a minus b, a plus b, 35, and so on. Find a and b. All right, for this problem here, I've set up a coordinate plane. You don't have to necessarily do so, but I want you to see some of the things that are going on. We have an arithmetic sequence. So we have to think about what that means. The sequence they give us, they tell us that it starts with 2, so that's like our first term. First term is like 2. We've got our second term would be a minus b, third term a plus b, and fourth term 35. So what we're going to do here is I'm going to go ahead and list these out in a table just so I can remember here. I've got my first term is 2. My second term is a minus b. Third term, a plus b. Fourth term, 35. If you recall, arithmetic sequences have a common difference between each of the term numbers, or I'm sorry, each of the terms. So as we go through and we look at this, we know that it's going to have a constant growth. I set up my coordinate plane here so that n represents my term numbers and the function t of n represents my terms, like you've dealt with when you've used arithmetic sequences in the past. So my first term I said was 2. So I'm going to go ahead and plot my point there for 2. Remember, this is discrete data, so it's not going to be connected. I'm not going to have a line through here, but I am going to look at the shape of it because the fact that it's linear or constant growth is very important. I can't really plot my second and third points because I don't know the values of a and b, but I can plot my fourth term, which is going to be 35. So if I go in here at 4 and I go all the way up here, I'm at 30. This would be 32, 34, so we'd be about right here. That would be our point where we're at 35 right there. So I can get a kind of general idea because I know that this would be a linear growth here. So my second term should be somewhere around in here, and my third term should be somewhere around in there. Since we have constant growth and we have that common difference that we're adding each time, if I can figure out what the slope of this line is, it can help me to figure out what values my second and third terms are. So let's do that. Let's look at if you received the information here that you knew you had a line that extended between the points 1, 2 and 4, 35, you could find your slope of that line. You do the difference in your y's over the difference in your x's. So we'd say 35 minus 2 over 4 minus 1. I'm going to go ahead and just label that as a slope because that's what I am using it for. 35 minus 2 is 33, and 4 minus 1 is 3. That means as we've gone over 3 terms, or 3 term numbers, the value of the terms has increased from 2 all the way up to 35. So it's gone up 33 units there. So if we take that 33 and we divide it by 3, that means that each time we increase our term number by 1, the term is going to increase by 11. So if we think about that information as we go back to our table, if we're starting at 2 and we know that we are going to increase this by 11, we know that the value of a minus b here should end up equaling 13. And if we take our 13 and we add our common difference there, which is like our slope, remember, If we add 11 there, well, 13 plus 11 is going to give us 24. So our a plus b should end up equaling 24. And just to make sure this all works out, if I add 11 to my 24, I should end up with 35. So right now I know that my value of a plus b should equal 24, and my value of my a minus b should equal 13. If we look at our second term here, our second term in our sequence, if we say it should equal 13, well, there's 10, there's 12, there's 13. That seems to be in line. And my third term is 24. If I go up to my third term and then 20, 22, 24, that seems to make sense. That would be a constant growth there. So since I know a plus b equals 24 and a minus b equals 13, this works out for me because now I can use this as a system of equations. I can take it and solve for a and b. Let's take it. I think that probably the easiest way to do this one would be using elimination, but you could use substitution if you wanted to. Elimination. I already have them both in standard form, and I notice here that I have a positive b and a negative b. So if I took these and I added them together, a plus a is going to give me 2a. These are additive inverses, so they are going to give me a value of 0. And then 24 plus 13 is going to give me 37. Not the prettiest number, but sometimes you get numbers that aren't whole numbers there. So we've got a is going to equal 37 divided by 2 should be 18.5, or 18.5. Now to go back here and figure out what b is, let's just take that 18.5 and plug it into one of these two equations. Let's do 18.5 plus b should equal 24. Subtract my 18.5 from each side, and I should get that b equals 5.5. So I've found here that I think that 18.5 would be my value for a. My b I'd say is 5.5. Well, let's check it here and see. Let's just plug them both back in. We already know right now, because we just solved that 18.5 plus 5.5 gives us 24. And when we do 18.5 minus 5.5, that should give us 13. Well, half minus half gives us 0. 18 minus 5 gives us 13. We know that that is going to give us the correct answer. So it asks us to find a and b. Just to make sure we emphasize our answers, a should equal 18.5. B should equal 5.5. This is problem 4-26 from your homework. If you have more questions, please make sure you ask your teacher. This is not the only way to do this problem, but this is just one way that I wanted to express it. Remember, arithmetic sequences, we use discrete data and they have a constant or linear growth there. Use that knowledge that you already know to help you as you're solving these problems. Thanks for listening, and good luck.